Alright, in this video I'll be talking about negations of conditional statements and De Morgan's laws. So let's go ahead and get started. So here we're going to talk about negations of conditional statements. So the negation of if P then Q is P and not Q. So basically we know that this has the meaning that P implies Q. Or if you have P, then you will have Q. So again, I like to say P implies Q. Well, here you have P and you don't have Q. And so that is the negation of the conditional statement. So we're going to use that to write the negation of if I live in Dallas, then I live in Texas. So first of all, we have two simple statements here. I live in Dallas, that's going to be P. And then my other simple statement is I live in Texas. And so the symbolic, or the symbols for this statement are if I have P, then I have Q, or if I live in Dallas, then I live in Texas. So the negation is I live in Dallas and I do not live in Texas. So I live in Dallas and I do not live in Texas. So that would be the negation of the original statement we have here. All right, let's go ahead and move on to the next problem, part B. If it is the weekend, then I do not work. So when we make these statements, we'll make them positive statements. So first of all, we'll have it is the weekend. So it is the weekend. Then I do not work. Now this is P here. And remember, we want Q to be a positive statement, not a negative statement. So we will say I work. So what we have here, I do not work, is not Q. So what we have here is if P, then not Q. So again, to negate it, it would be to have P and not Q, which is just Q. So we have P and Q. So it is the weekend. And let's see, I do not work. So actually, and we said Q is I work. I thought I had it wrong here for a second, but that's correct because that's not Q. Q is I work, so it is the weekend. I'm sorry, I said that wrong. The original statement was if P, then not Q. So we have P and not Q, which is P and Q. So it is the weekend and I work. All right, let's move on to C. I would encourage you, actually this one's a little bit different. I was going to say you should try it, but it's a little bit different. Because notice we have a quantified statement here. If there's an ice storm, and then this is the quantified statement, all schools are closed. So our P statement is there is an ice storm. All schools are closed would be Q. it is a positive statement. All schools are closed. If we wanted it to be negated, we'd say not closed. All right, so all schools are closed. So this is P implies Q, or if P then Q. The negation is when we have P and not Q. So we're going to have to negate all schools are closed. Now I'm going to put a diagram on here that we used way back in section 3.1. You have all A are B. We have a little cross here. The negation of that would be some A are not B. And then if we have some A are B, the negation is no A are B. So in our case, we've got to negate Q, which says all schools are closed. Well, let's go ahead and first put our P statement. There is an ice storm. There is an ice storm. And so we don't have that, we have the opposite of all schools are closed. So notice all are, that's here, all A are B. So we'll have some, for the negation, we'll do this statement here. Some schools are not closed. So again, we go across the diagonal to negate what we call a quantified statement. So this is our P and this is our not Q. There is an ice storm and some schools are not closed. Remember, that means at least one school is not closed. All right, so that's our answer there. Let's go ahead and move on to the next page. So here we're going to talk about De Morgan's laws. So it says De Morgan's laws can be used to negate conjunctions and disjunctions. So we have not P and Q is congruent to not P or not Q. Now we're going to show that in a truth table in just a minute. Remember, that's how we can show that two statements are congruent or not. The other one would be not P or Q imply or has the same meaning or is equivalent to not P and not Q. So notice it says to negate a conjunction, negate each component statement and change and to or. To negate a disjunction, negate each component statement and change or to and. All right, so let's go ahead and show the first De Morgan's law here is true. That's this one here. So first of all, we have P and Q here. Now we know P and Q is usually false. It's only true when both P and Q are true. So we have true, false, false, false. Now not P and Q would be the opposite truth value of what we have in this column. So false, true, true, true. So we have the first statement. Now we're going to build the second one here. Not P would have the opposite truth values of P, so false, false, true, true. And not Q would be the opposite of the Q column, so false, true, false, true. And so here we have not P or not Q, so this is an or statement with these two columns here. Now remember, an or statement is usually true. It's only false when both statements are false, which is what we have here. Notice in all the other cases we do not have false, false. As long as one or both are true, the or statement is a true statement. So notice these two columns have the same truth values, and so that means these two statements are equivalent. You could do the same thing with this one here. There's a good chance you have to do that in the homework. So let's move on to example 2. Write the negation for each of the following statements. All right. So it is not true, so we're going to have a negation, that I did the homework. So let's see, we'll call P, well actually we'll just do this. We'll put the P here and Q here. So P is I did the homework, and Q, I studied for the test. So that would be, it is not true, or it's not the case that P and Q. Now we know that's equivalent. Let's see, that's the 3 bars, to not P or not Q. So we're going to say, I did not do the homework. I did not do the homework. And then remember we use or, so it's the opposite of what we had, which was and. Not Q, and I did not study for the test. So the original was, it's not true that I did the homework and studied for the test. This would be equivalent. I did not do the homework, or I did not study for the test. I wasn't able to say that I did both. All right, so I would encourage you to try B. It's going to be very similar, and then stop the video and then watch it. All right, let's see how you did. So here you have, it is not the case, so we're going to put that not out front, or the negation symbol, that Taylor Swift is a professional tennis player. That'll be our statement P, or a basketball player, which basically means Taylor Swift is a professional tennis player, or Q, Taylor Swift is a professional basketball player. So we have not P or Q. Whoops, I wanted to write or. We're going to use the or symbol. Remember, that's equivalent to not P, and instead of and, it'll be or. Oops, here it's or. I need an and here. Goodness gracious, just the and symbol is all we need here. And then not Q. So again, I'm just using this property here. So let's go ahead and write the statement. So not P, Taylor Swift is not a professional tennis player. Or and, well, we can just say, well, we have to say not a professional basketball player. You kind of read into the fact that it's professional tennis player or basketball player that this is professional too. I guess you could go without the word professional. But it's and not this case, and not, you could say a basketball player or a professional basketball player. So it is not the case that Taylor Swift is a professional tennis player or basketball player. which means Taylor Swift is not a professional tennis player and not a professional basketball player. Again, I think it's possible you might leave out the word professional. Either way, that's what it would look like. And that would be a reasonable answer. All right, that's it for this lesson. If you have any questions, let me know.